Hi and welcome. I'm trying to learn particle physics. Today, 3 generations of particles, and after we've done it, we're gonna do ECU tendon training. The ECU tendon is here, and if you participate in the ECU tendon training, then it's well at your own risk. We go to incredible lengths to gather electrons. We generate them in vast power stations, string cables across the countryside to bear them to us, and install sockets in the walls of every room to zap them into our devices. So the meaning electricity are electrons. Our dependence on them makes it a shade embarrassing that we don't fully grasp what they are. So we're saying we're using them so much, but we don't really know what they are. It was 1897 when J.J. Thomson observed rays that would bend under the influence of an electric field. The charged particles that orbit atomic nuclei that we now call electrons. By the mid-1930s, we had found the other components of atoms too, the proton and the neutron. But just as things began to look tidy, confusion descended again. In 1936, a pair of physicists in California who were studying radiation from deep space noticed a particle that was negatively charged, like the electron, but whose path bent less sharply in an electric field, suggesting it was heavier. Okay. In 1896 was J.J. Thomson looking at things, and these rays, were able to be bent under an electric field. And in the 1930s, there were protons found and neutrons. This about 1897, these were the electrons. But now in 1936, there were physicists in California studying on another particle, and it was bending not so much. And that means that that element, whatever, or that particle, was heavier. The appearance of a muon, a particle like the electron in every way, just of 207 times the mass, was so unexpected that physicist Isidro Rabi responded by saying, "Who ordered that?" Okay. What we had there as particle was probably a muon. It has 207 times the mass of electrons or the other things, probably electrons, and that would meant that it was not bending its path so much if an electric field was having an influence on it. 4 decades later, the plot thickened once again. Starting in 1974, a series of experiments at the Stanford Linear Accelerator Center, SLAC, in California, uncovered another sibling of the electron. This was 3,400 times as massive and named the tau. It is as if someone has put an electron through a Xerox machine and set the number of copies to 3, says John Ellis, a particle physicist at King's College London. Okay, they found more or less the electron in 1897. There was a ray, but I don't really know what a ray is, and it was able to be bended through an electric field. They found something else, and it was 207 times as heavy. It wasn't bending so much, but it was not a muon. And then 40 years later, we found another thing that was 3,400 times as heavy as the electron, and they called it tau. So we have an electron, muon, and tau. Can we see that here in the list? Here's our electron, muon, and tau. And here we have an electron, muon, and tau. The electron, muon, and tau. They were respectively whatever neutrinos. Electron neutrino, muon neutrino, tau neutrino. It is as if someone has put an electron through a Xerox machine and set the number of copies to 3. As the contours of a standard model have become more delineated, delineated, it is as if that mysterious photocopying has been carried out right across it. All the fundamental particles of matter, the fermions, seem to come in three successively heavy generations. It is an absolute puzzle, says Martin Bauer, a theoretical physicist at Heidelberg University in Germany. Everything would be consistent with just one generation. Why exactly the others are there is just not clear. One way to explore further is to test a principle called lepton universality, which roughly states that all leptons behave alike. It means, for instance, that when larger particles decay, any leptons in the fallout should be produced in equal proportions when the mass is accounted for. In 2014, scientists at the Large Hadron Collider's Beauty experiment were studying the case of B mesons. These particles are made of two quarks and can decay in many different ways, making them a pet test bed for physicists. This time, something odd came to light. There were 25% fewer muons than electrons produced. Yeah, so that means they had found always an electron and muon and a tau, and now we had not so much muons as electrons, and that doesn't really fit you. Flagrantly violating the principle of lepton universality. So that's what I wanted to say. Response. Better. Would have been better one. It was flagrantly violating the principles of lepton universality. That's not okay, and we're going to ending with that. And if you are here for particle physics, you can go directly to the next part. We will do now ECU 10 training. If you stay here and participate in the ECU 10 training, then it's better at our desk. Go to the state stance, arms next to us, and we're doing the flat gate. We're bringing the fists down and up. And now we'll counterfight money check fists and bring them up, ending it down. We're having three rules. The first rule is that we're stopping immediately as soon as there's pain. We're holding it here longer. I don't know, we're going to hold it. The second rule is that we're going only as far as we can go with a little bit of effort. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. If you'd like to take a break, do it. And do the next exercise. I'm going to use a tennis racket. You can use also a dumbbell. A tennis racket is light. It has just around 300 grams, so whatever you use, do it in accordance with our three rules. For Manika Neko, have the elbow in, take the lower arm, and bring the arm over to one side. And then over to the other. And another time. Now with long arm out. One more time. And now with your arm. Elbow in, slowly on to one side. And the last time. Now with the long arm mode, same. And the last time. And now over to the next exercise. The garbage truck's clever arm. No, it is not. It is first the harvest over. Take the leg from top or whatever, and lift the arm up and bring the arm over. And back in again. And down. And another time. Arm up. And over. Back in. Down. And now the garbage truck's grabber arm. Palm faces upwards. Lifting up. And bringing it over. Now same with the other. Palm facing upwards. And the last time. And now you can use a towel or a t-shirt or sock, and you just press with good force onto it. And when you bring the wrist up, and again up. Again up. And another time down. Now with your other hand, press with good force into it and bring the wrist up. Moderate close. And again down. And last exercise, just press with good force on it. Neutral position. And second. And that was the ECU tendon training. I think very much, and until next time.